Hey, what's going on, guys? GameOS here. In this video we'll start implementing an interactive shell for running boot sector games under our real mode operating system that we're developing called GameOS. But before we start, I'd like to show you the draft that I came up with so far, which is kind of like a working prototype, and I didn't even manage to test this on a real hardware. So without further ado, let me just show you this, then we'll go for a quick overview of the overall architecture, and then we'll start, then we'll fix existing code a little bit, because I made some small error, well, a couple of small errors there, but big enough to, to not work properly later on. Okay, so yes, just want to run the version I have. So I'm running this in Camel currently. So I only have 3 games now, and what the shell provides, so we can type, we can erase, we can move the cursor, however, okay? And if we type some gibberish, it tells the game is not found. If we just type, it just gives like the new line. That's pretty it. But if we type one of these words, which stands for a certain game that we have within our kind of like file system that I've been talking about in the previous videos. So, and by the way, yeah, okay, let me just run this first and then I'll walk through the details. So let's say I want to play Snake, and here we go. So I can play Snake, and I've modified the game slightly a bit to be able to exit back to the operating system. I've just added jump instruction with the memory location occupied by the shell. So just a bit altering of the original game, but if I didn't do this, it would just be playing this game forever, because boot sector game is not thinking about going somewhere. Okay, so yeah, if I just press Q, I just escape from the game. Now let's play the Tetris that I've already been demonstrating. Okay, so we can play Tetris. Well, here unfortunately I didn't yet modify the code, so we actually can't escape from here. So I just need to reset the stuff. All right, and another game is Arkanoid, like, if I'm not mistaken, that's the proper name for it. Absolutely amazing masterpiece by Oscar Toledo that we can play. And there is no other way to escape from here unless do like this, drop the ball. Also like my weird modification, but that's how it works currently. So I've been trying some other games as well, but not all the games working straight out of the box. Some needs modifications, more or less. So this gives me another idea on the distribution, let's say, of this kind of like operating system. So I'm thinking about some sort of a packs. So by saying pack, I mean the image of the entire well, the floppy image that would be written to the USB flash drive, as I've been explaining many times before. The size of the image is like the floppy image, but it operates like a normal, well, like, okay, just forget that. So I will try to embed all the games I can, but then I'm really interested to re-implement the games I'm interested in on my own, and make so-called CMK pack, code monkey game pack as well, and probably then we can go for some, not only the games, but some kind of like apps to work with this operating system, to do something else but playing games, maybe developing games. I know this sounds weird, but well, we'll see. I have many plans, but it's not clear exactly what's going to be happening. But anyway, so this is how it works. So this is the exact shell that we're supposed to be implementing. And now one of the major leaps I've managed to do. So my original shell did contain all the data within the shell itself, and that was a problem because it did limit, it did add the limitation. I mean, like the number of entries is very limited because the most of the sector is taken by the shell code itself, and we have really like just a few entries here, and that's pretty it. But I've managed to use the pointers to the variables that are stored in the different location, and they are loaded from this file, and this will load me to actually use so in one place, like in one segment, I'm reusing the variables from the other segment. Okay, and here we're coming directly to segmentation, to memory segmentation in real mode, and this is a very sensitive topic. So if you're developing something within the real mode, it's incredibly important to figure out how this memory segmentation works, because otherwise you can get confused all of the way because of notation, how the memory is kind of being printed, like not printed, like being defined, let's say, and how the jumps works, how the far jumps works, and things like that. So here is the deal. So the problem is that the absolute address is 32-bit. However, the registers in 16-bit mode can only take 16 bits. Hence, in order to reference different segments, we need to use a specific notation. And notation looks like, oh my god, where is that? I've just seen this. Yeah, this is it. So in real mode, you use a logical address in the form A and B. This is translated into physical address in the following equation. So we have A is the segment and B is the offset. So we'll now be working with this directly. I will just give a link in the description below this video. I will also add the segmentation part so you could read through to figure out how exactly it works. And I would now focus on the practical implementation of how we can make use of this stuff. Okay, so sorry guys, that's a bit too much on my desktop, but anyway. So we're going to the no, not here, to the tutorials. This is the working draft. So I just want to create a new tutorial folder and rename, and this is going to be part 3. Okay, part 3, open terminal here, and let's run whatever we have from the previous part. Nothing special, we just print the string from the second from another segment that where we have loaded the sector 2 data, which is our file system. Okay, so before I forgot, let's go for some altering. So I just want to open the boot. Let's make it full screen. Well, we don't yet have the shell, right? Yeah, that's fine. So let's create the shell.asm. Oh man, what have I done? Shell.asm. Okay, would also open this, but for now, yeah, just okay. And yeah, I forgot one more thing. So let's actually start traditionally with our memory map. Okay, so what we have so far, we have a bootloader. All right, we got the files, and yeah, so here, by the way, it's not exactly the precise I made a little mistake here. So we take 7E00 plus 512. Yes, we do this. Oh man, sorry. Again, 200s is 512 decimal, 200s in hexadecimal. Okay, so 7E. I'm calculating the physical memory address for our shell. We're gonna be putting this 00 plus 200s. Yeah, this is 8, but we need to say -1 and 7FFF. So here we have 7FFF, and here we have 8 thousandths, and now we need to say, so plus 1 plus 2 hundredths and minus 1. So this is the address, okay. And another 512 bytes chunk, okay, bytes, and here we'll have our shell. And on the floppy image, we will have our shell in the third sector, sector 3. So yeah, by the way, here I can also say like sector 1, okay. Here I can say, this is very important, guys, because otherwise, yeah, blind copy pasting doesn't work for assembly and real mode. Yeah, just you really need to know what are you doing. And yeah, here I probably made another mistake. So if I take nope, if I take 2 hundredths plus 2 hundredths, yes, and minus 1, 3FF, so here I need to specify 3FF, and here 4 hundredths, I'm sorry, not like this, 4 hundredths, well, probably the absolute address would contain way more trailing zeros to represent the actual size of the storage device, but I just want to keep it like in the format as the RAM goes, so don't get confused by this. And we have, so now, okay, plus 1 plus 2 hundredths and minus 1, okay, 5FF, 5FF, okay, another 520 bytes, okay, and here we have the shell code, and this is the sector 3. Okay, great. So let's get back to the boot sector. So another important thing that I forgot, well, I actually said in the previous video, I said that we don't need to initialize the DL register. However, I was horribly wrong, so we actually should initialize it, even though it works here naturally. I'm sorry, move DL. And the constant for the hard drive is hexadecimal 80. I guess because the BIOS knows that we're the BIOS knows that we're booting from the hard drive, well, from the USB flash, but it's treated to be as a hard drive. It probably sets this value automatically even on the real hardware. But later on in the shell, I would be changing the value of DL for the purposes of the shell functionality, and then we need to restore that. Always, we need always to restore this to this value, and it's just going to be reusing this code in the shell. So, hope this is clear. So here we initialize the HDD, so HDD code. Okay, specify HDD code. Okay, now this is good. Okay, so the way how we put the second sector with the file system into the random access memory remains the same, but now we'll go for a bit of a different thing. So we don't want to print this string from the sector 2 any longer. Okay, you can actually get rid of this. And now we need to do what is known as loading an extra segment. Okay, so first, so let's go to the memory map. So we need to load to this exact address, but in order to actually jump there later on, we can't use this sort of a notation as we did, like we did here, where, oh my god, here. We can't do it like this. So if we have a look at the formula again, so this is the formula to calculate the actual physical address. Okay. So here we're having the segment, and we need to multiply it to get the actual physical address, to get this like address. So okay, so we have the physical address. I just really want to go through this in great details because it's incredibly important. Is where the shell is going to be loaded. Okay, now we can say that physical address is equal to A multiplied by hexadecimal 10 plus B, where B is the offset within the segment, and this is the segment offset, or how they call it, the base address of a segment. Okay, the base of set. Well, I just mean that the second one is the offset within the current segment that we have, and this specifies. Oh my god, guys! I don't know. I just want to show you this. It's just a slightly different type of notation, but I hope this is gonna be clear. So in order to get this value, we need to take hexadecimal. Like this, right? Hold on a sec. Yeah. Okay. So, and this is gonna be 0 because we just don't care about it. We need only, we'll start at the very beginning of the segment we're loading to. And now this is the value that we would actually use to jump there. Okay, let me just start writing the code. So first we need to say move AX and this 800s, and then we need to initialize the extra segment ES, which is used in order to make this. So if I'm not mistaken, this is known as far jumps. Okay, so I mean the casual jumps within this segment where we currently are, and the far jump allows to jump to a different segment, let's say to a different executable, for instance. So we move AX to ES. Okay, then remember we've been specifying the BX, which is the offset relative to the current segment we're currently at, but in our case the BX is going to be equal 0 because we just want to start at the very beginning of the file of the shell, just the very beginning here. Okay, and then we need to specify the sector that we want to load. This is sector number 3, so CL is going to be equal to 3. And yeah, this is pretty. Then we need to call our read sector. Yes, call the read sector. Okay, and then we can jump there. Okay, yeah. For now, let's just stuck in the infinite loop. All right. So yeah, I'm just thinking about this explanation. So let's say, so here is the formula to calculate physical address. I'm just trying to explain why we initialize AX with this value, okay? Because we want to initialize our extra segment in this way. Okay, and the segment init is this one. Okay, let's say because this is how the this is how we can obtain a physical address from this segment using this segment. Okay. This is how we can obtain a physical address from using this segment. Okay. Right. Yeah, so I hope it's clear. And this is needed to initialize an extra segment for our shell to boot at, to boot and run at. Okay, this need an extra segment for our shell to boot into and run there. Okay, so let's provide the comment trees. So this is the init the, I'm not sure, is this called the segment value, or just want to be clear. I understand this, but I just want to be clear, like the terminology. So how A is treated. The base address of a segment is A multiplied by 10. So now what the A is. So you use logical addresses. So base address is A multiplied by, but we're not multiplying this yet. Okay, segment. A equals 64K segment. Okay, let's do so. You need the segment. Okay. You need extra segment, the name of the register. Okay. You need local offset within the segment. Even if I just make some mistakes in the terminology, still the structure is working. So as long as you understand the structure, it doesn't really matter that much how exactly you call it. Okay, so here we want to read which sector to use. Yeah, and by the way, hold on a sec. So here I need to specify sector 2 on USB flash drive contains file names. Okay, and here sector 3 on USB flash drive contains shell code. Okay, shell binary code, binary executable. Okay, then we just read the sector. All right. Okay, and yeah, this is it for now. So yeah, let's go let's go and test it. So if everything is working. Okay, so no errors. It didn't say fail to load. So this should be okay. Okay guys, now before actually jump into the location where we have initialized our shell, we need to write some code here. But before writing some code, it's reasonable to add this to our build toolchain. So if I run my run shell script, so the next thing we want to assemble shell, right? So here, yeah, by the way, I can do this, actually should do this after here, it doesn't matter, but just for clarity. So here we have the shell asm, turn it to shell.bin. Okay, so minus 1 sector here, so minus 3 sectors, bootloader, files, and shell. It would be 77. Okay, and now concatenating all of them, so files, and then so the first sector, boot sector, second is the files here, and here we use our shell, so shell.bin. Okay, so we have first the boot sector, then the files, and then the shell, sector number 3. Okay, also we want to clean the shell.bin after, and we're done basically. So yeah, now let's start writing. Now I think we're ready to write the shell code. So I'm going to be reusing the code from the bootloader heavily. So here we're going to be having the shell. Okay, so bit 16 is the same, but the origin here, and it's important guys, so the origin here, as far as we need the actual origin, we need to, what is done here, multiply our segment by 10 to obtain what is called as, oh my god, address, the base address of a segment. So here we have the base address of a segment, right? So, and this is gonna be 8 thousandths, and okay, and right. Just hold on a sec. Okay, I'm sorry guys, just been a bit distracted by the phone call. So this is the address where our shell is running, and I specified right over in here. And the next steps are quite pretty similar. And I want to initialize the data segment and an extra segment to 0 because the offset is provided by this org directive, which stands for origin. So here, yeah, tell NASM that we're starting at, so let's say here, copy address and the boot sector. Okay, and here we start at yeah, actually, yeah, we can also just give the full offset to make it clear, 100% clear. Okay, and here we have the shell. And not, yeah, this is the bootloader. Bootloader. Okay, well actually here, okay, no, just All right. Let's say boot sector address, and the app we're running is the bootloader. This is it. Okay, now here running as this and this address, and here shell is living. Okay, so it's the same thing as we've done before, and at the very end we need to fill with the trailing zeros, because every file within our image should be exactly 512 bytes. Okay, so just need to make it 512. Okay. All right. So what else? Now let's port the print string procedure, which is going to be absolutely the same. And let's move it here, right? And yeah, probably the very first thing to consider, we would like to read from the files from this address. And yeah, I just want to have a look at the files. So yeah, this might be left like this for now. We'll later alter this, but for now this might be just like this. Okay, and run shell ASM 512. Okay, and now to print something there, so we can say move si, and okay guys, I don't remember. Hold on a sec. Should I use 80 or yeah, I should probably like this. Yeah, or yeah, this should be and call print string. And if I did everything properly, it now should print hello from sector 2, but this would be printed from the shell already. But before that, so do we have the build already completed? Yeah, we do. Seems like. Let's have a look. And something has gone wrong. Okay. Okay, I'm sorry guys, I don't remember how exactly. Oh, what am I doing? I'm sorry. No, not the 800s, not the 800s. From this address. Yeah, this is the shell. It reads from the shell. It's weird stuff. Okay. 7E. Yeah, I'm not sure about multiply by 10 or not. We'll now see. Maybe, yeah, probably. Nope. Okay. All right. Okay, guys, it's not the problem. Problem is not here. It was okay. The problem is that we didn't actually jump there. Okay, we just stuck. So we need to jump to this segment, and the offset is 0. Jump to the shell code, to the shell executable, and run it. Okay. Now this should be fine. All right. So now this should be, yeah, and hello from sector 2. And white prints Tetris. This is a bit strange. Is there a terminated character missing or what? Nope. Hello from sector 2. This is a bit strange, to say at least. You shouldn't be printing. Okay. All right. Hold on, guys. I'm trying to figure out what did I do wrong. Calling the print string. Oh, maybe because I forgot to return here. Nope. No, it's not the case. What's wrong there? Yeah, something's wrong happening. Sorry guys, just hold on a sec. Okay, sorry guys, that's because the instruction pointer goes further on and tries to execute whatever is available in the memory, so we need to prevent that by either specifying the infinite loop like this, but even better idea, so just to show this is going to be working, so now we stop where we should have, and by the way, if we just try to call print string a few more times, in this case we would actually print the rest of strings, because it's like we have the Tetris, the bricks, slides, because we increment the SI anyway within the print, so that's why it happens like this. But we don't want this, and also here we actually want to specify the shell loop, and we're not going to be writing it in this video, but jump shell loop, but I just want to provide the placeholder, so this is the main OS loop. Okay, and run, and still working as expected because we just stuck here, and that's good. Okay, so I'm pretty satisfied with what we currently have. And now, well, before actually implementing this, handling user input, editing text, like deleting the characters and all this stuff, like picking up the proper file name. Well, by the way, we can already reference the variables being loaded to this address from this file. And if we want to get an offset for the next variables, we can just add the number of bytes, and that's how we get the offset. This is going to be covered later on. I know this is weird, but that's the price of kind of like not being bothered by implementing the operating system, which I think that's really redundant here. So we can just use it this way, and it's not even that point. Well, anyway, doesn't matter really. So the most essential thing of what the shell is actually doing is it executes some another games or apps or whatever. So now we will have now I have this games folder, and I just copy this games folder, so it contains the images, so I just paste it here. So games contain the images for 3 games. Let's call this one, actually it's not Tetranglus, it's the Tetros. Tetranglus doesn't work on my hardware for some reason. That's another Tetris clone. Okay, brick, snake. Okay, and now we need to add these guys to the floppy image. So let's go. So now we open the calculator back, and we have 400s plus 200s, 6 hundreds, okay. And so this is where the first game is gonna occur, and plus 200 is 80, minus 1, 7FF, 07FF, 512 bytes. And this, instead of a file system, I'm maintaining this table. So yeah, so here we'll place the snake. So this is gonna be sector 4. Okay. Now here we'll have, this is really fun, guys. I don't know about you, but for me personally, this is really fun. So plus 1 plus 200s minus 1, 9FF, 09FF, another 512 bytes. And here we'll have the tetros. Okay, sector 5. And now plus 1. So this is gonna be A00, right? So minus 280. Yeah, plus 200s 800. A00 plus 200s C00, okay, minus 1 BFF, BFF, 512 bytes, and this is gonna be bricks, also known as Arkanoid if I'm not mistaken. So here is the sector 6. One little note, guys, that the actual images for games are already being altered slightly bit to be, well, let's call it compatible with GameOS. It's not really that most precise word ever, but anyway, I just made some minor adjustments to make it work smoothly. Okay, and well, Tetros, by the way, still is not gonna be able to escape from, from the loop, so I will need to alter it a bit later on. Well, probably as far as this is tutorial on this operating system stuff, more like that, rather than the games, I will probably just do it and provide the pack with the third-party games. And when it comes to implementing my own games, I would just better go through this process with the details on how to drop back to the shell, basically. Okay, so yeah, that would be the guide on how to make your game if you're developing the game that you want to be running under this operating system. So what in particular you need to do? So basically, it's just like on escape press, you need to jump to 8,000 hexadecimal where the shell is. Jump here. That's pretty it, and just getting back to the shell loop. Okay, so now as far as we have, so now let's add them here. So we say games and snake dot image and copy paste. Then the tetros, the order matters, should be exactly the same as here, just to avoid getting confused. And then the bricks, and then the bricks. Okay. Okay. So let's compile it, run, and I just want to inspect XXD GameOS image. I just want to inspect the image so that I could Okay, so the bootloader, boot signature, file names, shell, rudimentary shell here. Yeah, it takes so many bytes, so few bytes here. This is cool. And here we have, oh my god, the snake, right? Yeah, ends with the boot sector, boot signature, which is okay, because this is the boot sector game. Then we have the tetros, same thing, and then we have the bricks, same thing, and even some free bytes available here. It's cool. Okay. Okay, maybe they're not free. I don't know. Okay, so now to how to execute. So execute means we need to load the certain game from a sector and put it to the boot sector, because it's intended to be running in the boot sector, right? So that's the reason why I want to load this exactly where it would be loaded otherwise if not running under the GameOS. It's just start, like, if computer boots to that, just find the game finds itself in the boot sector. So that's where I want to put it, basically. So I want to take this read sector procedure from the boot sector and paste it to yeah, after the print string, paste it here. Yeah, and by the way, guys, another thing before I forget, we need this trailing zeros. We have the trailing zeros in shell. Okay, yeah, we have trailing zeros in shell. Yeah, so sorry, yeah, that's it. I thought this is the boot. Yeah, all right. Oops, nope. Okay. Oh, this is the boot sector. Oh my god. Yeah. So read the sector. Okay, and now I want to provide, so execute game, and let's create a procedure to execute the game, the boot sector game. All right, and I'm just wondering, do we need to return after? Okay, hold on a sec, I just need to quickly check that. Well, at least I didn't return in my draft implementation. Okay, so now we need the code. Now we need the code, exactly the same code as we've been using here to load the shell. Let's take this code. Just don't forget to, not to forget to alter the commentaries. So now we jump to 7C, we initialize the 7C0, and here 7C, this is the boot sector, 7C. Probably it might make sense to define some constants for that, and probably I will do this just for clarity. Yeah, because it's not really handy to bear in mind this, to keep in mind this numbers. So call the sector, and now for now we're going to be specifying, no, actually the sector, no, this is okay. Yeah, this is okay. Which sector? Yeah, we'll later we'll start storing this in DL later on when we implement the shell. But for now, we just make it by hand. So starting from, so sector 4 should run the snake, 5 tetros, and sector 6 should run the bricks. Let's try them one by one. So starting with the sector 4. Okay, so we're reading the sector. Putting this to the boots, reading a sector from the image, from the storage image, and then put it to memory at this address where the boot sector game would normally be loaded to, and then we make a far jump here, there, just like we did a far jump to, I hope this is called far jump. Hope I'm not mistaken here. Yeah, this should be called far jump. Yeah, and by the way, far jumps do adjust the code segment, which holds the instruction pointer to the next instruction to execute, and this doesn't happen in case of local jump within the single segment. I guess, well, yeah, I guess that it should be true. Okay. So jump in there to the boot sector. Yeah, now this is not going to be working because of the shell loop. So for now we can just comment out our shell loop, and we're gonna stuck in the game. So we're not going to be returning from there, but for now we are not interested because we don't yet have a shell to return to. Okay, so if I did everything properly, it now should start the game of Snake. What have I done? Nope. Well, it doesn't. Okay, we have, okay, error message undefined. Okay, we need to grab the error message from here. Copy. And so how did I? Messages, yeah. Messages. All right. And oh my God, we do run the Snake, and we're not doing this like from the very beginning, but we do load the Snake from the shell, believe it or not. Even though we don't have a shell, like the REPL loop, so-called read, REPL, read, evaluate, print loop. Yeah, that's what the abbreviation stands for, read, evaluate, print, and then loop back. So we have the Snake, and it's running in the boot sector. This is so cool. Okay, I pressed Q, which actually this should jump back to the shell. Oh no, it doesn't, because yeah, I still need to alter all of the games because they were relying on a different location for a shell. So yeah, it just goes gibberish here. Doesn't matter. So yeah, I would prepare the binary images for the games later on, so to make sure that they would return back to the shell. Yeah, probably I would even show you that, guys. I think that might be interesting for those who want to develop for GameOS, like what in particular you need to do in your game so it returns back to, yeah, I think to return back to the to this shell loop. I think that's this might be a good idea generally. Okay, so now let's try to run game number 5, and we should now run Tetros. And oh my God, we have this. Cool. We have the Tetros. Great. And finally, sector 6 should be Arkanoid. And we got it. Okay. All right. And all this stuff works on the real hardware, by the way. I've checked that. I'm not going to be demonstrating you this in this video, but trust me that it will work. I'll demonstrate when the entire shell is going to be working. Well, okay guys, so I think this is it from my side for this video at very least. So yeah, in the next one we'll start implementing the shell loop, so taking the user input, evaluating whether the game exists or not, and if so, we would be keeping the count of the games and using the counter to serve as the index dynamically. So here we just hard code the game, but we're going to be this value is going to be changed dynamically. So depending on what game did user type into the shell, the corresponding game would get loaded. That's pretty it. So yeah, thanks for watching. See you next time. Until then, and take care.